current out of the plane of the paper like this. Current is going upward like this. Then somebody asks you to make the pattern of the magnetic field on the cardboard. This is the cardboard. This is cardboard, and there is a current, there is a wire that is going through the hole in the middle of the cardboard, perpendicularly outward, and the task is to make a magnetic field. And remember, it is a 3-mark question. How mark? How many marks? 3 marks. Pay attention. How to get 3 out of 3? Number 1, you have to decide what type of what will be the shape of the magnetic field. So if you give a thumbs up with your right hand to somebody, the thumb is showing you the direction of the current, and curve of your finger is the direction of the magnetic field. So you will all believe that there will be a circular magnetic field. So when you make a circle like this, you get a mark, but we have to get 3 marks. So we will be making 3 circles. If you make 3 circles, you get 1 mark. But if you make 3 circles with increasing distance between them, now you get 3, still you get 2 marks. Number 1, first mark is for making circle. Number 2, the distance between the circles should not be equal. It should be increasing. The distance between the consecutive circles, I'm talking about this gap. This gap should be increasing. Is it increasing? Yes, it is increasing. Why it increases, I will tell you later. But first of all, the gap between the circles should increase, and you have to make 3 circles, and you still get 2 out of 3, not 3. What is the third mark for?
Direction.
Magnetic field. Yes, magnetic field is a vector quantity like all other fields. So we have to make the direction. So if you try to hold it like, if your thumb is pointing along the direction of current with your right hand, remember, you have to make a thumbs up with your right hand. So thumb is giving you the direction of the current. Your curve of the curve of your fingers is giving you the direction of the magnetic field. So I hope you might agree with me that the direction of magnetic field will something like this. Okay? Agree? Any confusion?
No, sir.
Good, good. In the second diagram, there is a current going down into the plane of the cardboard. If it is a 3-mark question, you have to make the magnetic field for this one. How should that be?
Mister, I think you repeat the process, but it's going to be upside down of the first one. It's going to be like upside down of the first.
It will be exactly the same. But the only difference will be
the arrows.
The arrows. So with your thumbs up, you will know that this time the direction of arrows will be like this. Okay. I hope this makes sense. Now, what if current carrying conductor? Let's say these are two current carrying conductor. This one is carrying current out of the plane of the paper. This one is also carrying current out of the plane of the paper. And they are very close to one another, so they will definitely be influencing magnetic field because of one another. So will they be attracting each other's magnetic field or repelling each other's magnetic field? To know that, you have to make at least one circle for each. And with your right hand thumb, you will find out that their magnetic field should be like this. Remember, the left side of the right wire and the right side of the left wire is supposed to interact with one another. So this has to interact with this one. Tell me, the two magnetic fields, are they in the same direction or the opposite direction?
The same
I'm
direction.
talking, no,
Opposite.
no.
Sorry,
I'm
opposite,
talking
opposite,
about,
opposite.
I'm talking about any point here. On the left of the point, there is magnetic field upward. On the right of the point, there is magnetic field downward.
Downward.
So this is two opposite magnetic fields. And what do opposite magnetic fields do to one another?
Attract.
They attract. Do you see that the circles are no more concentric? These circles were concentric circles. Like all of the circles had their center at the same point. But this time, circles are no more concentric. Okay.
Mister, I don't understand
What
something.
about
The
either you are having a very long pause or you're not saying
no,
anything?
no. The like using the grip rule.
Mhm.
Shouldn't they be the same? Like shouldn't they be like should they have the same? Should they like using like the current is going from right to left on the first one. The second one should be the same according to the grip rule.
Okay, and it is same. Look at the first circle. Do you see any
Yeah.
difference?
No difference, no difference.
But you listen. They have the same grip rule. The circles are identical, but the problem
Yeah,
is you're looking at the left side of the right circle and the right side of the left circle.
yes. Yeah,
If you want to compare whether they're same or not, you have to compare the right side with right side and left side with left side. But the
yes,
interacting part, the parts that are actually interacting with one another, is the right side of the left wire and the right side, left side of the right wire. And over there, the magnetic fields are in opposite directions. That's why they attract one another.
yeah. I understand now. Thank you, Mister. Thank you, sir.
Okay. Now, look, what if the two conductors carry current in opposite direction? In that case, just to check whether they will attract or repel, what I do is I make just one circle to see what is going on over here. And using right hand grip rule, I find out that their magnetic fields will be like this. Just look at these two signs and tell me, do you think these magnetic fields in the same direction or the opposite direction?
Same direction. Opposite direction.
So,
No, same. Sorry, same.
okay. Okay, listen. If magnetic field is in the same direction, they are supposed to repel one another. So what will happen is the next circle will be like this. Okay. Do you see the effect of repulsion over there?
Oh, yes, sir.
So in the next one, it will also be a complete circle, but I do not have enough space to complete a circle. So I will just make this important part of that circle. Same kind of circle will be here as well. So this is the kind of magnetic field should be there between the two current carrying conductors that are carrying current in opposite directions. So this is very interesting. If current is in the same direction, the two wires will attract one another. Two wires will attract. And if they are carrying current in opposite direction, then both wires will this, this is why this is sometimes confusing for the student, but all life in physics you've been studying that same repel, different attract, like positive repel, positive negative attract, north repel, south repel, north south attract. But this time it seems like it is opposite, but actually it is not. Because when there are two wires, the right side of the one wire and the left side of the two wire will have current in the magnetic field. If they have identical magnetic fields, the magnetic fields are in opposite direction. So that's why they are attracting one another. Okay. Now, you see that these 3D diagrams are very painful, and they require a huge amount of time plus skill. So this is a norm that we use in physics. Let's see. I don't think I would need to tell you the direction of this thing. Let me know when you understand what I'm trying to draw.
I'm missing.
Okay. So if it is flying in air, will anybody be confused what direction it is going? Is it going towards right or left?
No, sir.
No. If there is a person who's looking it coming towards him, the unlucky guy over here. This is person A. This is person B. So what will be the point of view of A? According to the A's point of view, can you all right now? You all must have a pen in your hand. Can you point that pen towards your eye? Like keep it at a safe distance. Do not poke it into your eye. Just keep it away from your eye, but point it towards your eye. What do you see? If you make the pen right, like pointing exactly toward your eye, and when you look at it, you should only be looking at a circle with a dot in the middle. When you make the pen point exactly toward your eye and you're looking at it with like from the front, you should be looking at a circle with the tip pointing in the middle. And what about the guy who's looking at this rocket from the back? He will be looking at a X. It means something is going away. That is why the person who goes away, we call him X. Ex president, ex prime minister, ex CEO means that person is gone. We are looking from the back. Okay, gone away. So X means for 3D diagrams on 2D surface. Cross means moving away from observer, moving away from observer into the plane of paper, board, or screen, like going away from you. Obviously, you're looking at this question on a paper, then it is going into the paper. If you're looking it on a screen, it means cross means into the screen. Cross means like thing is going away from you, and you are the observer. Means observer out of the plane of paper. Okay. So if we make a dot, it means it is something coming out towards you. You're looking at the rocket from the front. So rocket is pointing towards you. And when you see a cross, it means you're looking at the rocket away from you. You're the person who has fired the rocket, and so you're looking at the tail of the rocket, and you see a cross. In old literature, normally the example of an arrow is given. Okay? It is the same thing. Rocket sometimes makes more sense to the student. So who can complete this diagram?
Wait, Mister, can I just take a screenshot of what you just wrote?
Screenshot yourself.
I just want to take a screenshot of what you wrote on 3D diagrams on. Yes, thank you, sir. Okay, got it. Thank you.
Okay, now these are the two currents. Cross means the current is going away from you, and dot means current is coming towards you. Can you complete the field diagram? Okay. Can you complete the diagram? Can anyone complete the diagram? And there will be repulsion. Okay, I hope this makes sense. So when magnetic fields come closer to one another, they attract or repel each other. There are some important things. Number one, force between two current carrying conductors is it depends on product of both currents. So both wires experience same force even if their individual currents are not same. So if wire carries more current and the wires carry less current, so when they will be attracting or repelling each other, they will be exerting equal force, because the force does not depend on just the magnetic field of the smaller current. It will depend on the magnetic field because of the product of both. That's why force will stay same on both of the current carrying conductors. Okay, this is how the magnetic fields look like. Tomorrow we will start from the same point, and there will be class tomorrow as well. Okay.
Sir, what time? Because I might be busy because it's a weekend.
Hello.
Yeah, hello, sir. Hello, sir. Can you hear me?
I can hear you.